Good morning, students. Now we are discussing the chapter Force and Laws of Motions. In the last class, we discussed what is the definition of a force. What is the definition of a force? A push or pull on an object is called force. Okay. Then in the last class we discussed laws of motions, Newton's laws of motions. We explained first law of motion. What is first law of motion? Every object continues in a state of rest or of uniform motion in a straight line unless compelled by an external force to act otherwise. Okay. Then we discussed the applications of the first law of motion. Okay, so we know first law explains the force. First law explains the definition of the force. So in today's class, we have to discuss the Newton's second law of motions. Newton's second law of motion. Second law of motion is related with a new term, momentum. Momentum. Momentum is denoted by a letter P, equal to mass into velocity. So momentum is defined as the product of mass and velocity. We know about mass and velocity. The product of mass and velocity is called momentum. So momentum is equal to the product of mass and velocity. Okay. Then momentum is the impact produced by an object. Momentum is the impact produced by the object. So momentum is the impact. Impact means the result. Okay. Impact produced by the object. If the mass of an object increases, momentum also increases. Velocity increases, momentum increases. So momentum depends two factors. What are they? Number one, mass. Number two, velocity. Okay, mass and velocity. When mass and velocity changes, momentum of an object also changes. Then what is the unit of momentum? Momentum, unit mass. What is the unit of mass? Kg into. What is the unit of velocity? Meter per second. So kilogram meter per second is the unit of momentum. Unit of momentum. Okay. For example, two buses collide each other. What happens? When two buses collides each other, what happens? The impact is very high. Impact means the result of collision is very high. That result, that impact is called momentum. Okay. If the mass is high, momentum also high. If two buses collides each other with fast speed, what happens? The impact is very high. When velocity increases, impact also increases. When mass increases, momentum also increases. So momentum depends two factors. They are mass and velocity. Okay, so momentum is the product of mass and velocity. Okay, so now discuss the momentum. What is momentum? Momentum is equal to the product of mass and velocity. Momentum is denoted by a letter P. What is the equation to find momentum? Momentum equal to mass into velocity, that is P equal to mv. P equal to mv, where m is the mass and v is the velocity. Unit of momentum is kilogram meter per second. What is momentum? Momentum is the impact or result produced by the object. Okay, if a car collides with a bus, the impact or result is very high. The momentum is very high. If the two bicycles collides each other, impact is low. Why impact or result is low or momentum is low? Their mass is low. Mass is low, momentum is low. Mass is high, momentum is high. If vehicles are moving with fast speed, the impact will increase. Okay, this is the momentum. This is the momentum. Using this momentum, we have to explain the second law of motion. So next topic is Newton's second law of motion. Newton's second law of motion. Newton's second law of motion states that rate of change of momentum is directly proportional to the applied external force. Rate of second law of motion states that rate of change of momentum is directly proportional to the applied external force. What is the change in momentum? Change in momentum means final momentum minus initial momentum. Change in momentum equal to final momentum minus initial momentum. What is rate of change in momentum? Rate of change in momentum equal to P2 minus P1 by T. P2 minus P1 by T. That is called rate of change in momentum. Rate of change in momentum means final momentum minus initial momentum divided by time. That is called rate of change in momentum. This rate of change in momentum is directly proportional to the applied external force. Force is represented by a letter F. So F proportional to P2 minus P1 by T. P2 minus P1 by T. So F proportional to what is P2? Final momentum mv. mv is the final momentum. What is initial momentum? That is mu. mu is the initial momentum divided by t. What is v? Final velocity. U, initial velocity. Mass is multiplied with the final velocity, that is final momentum. Mass is multiplied with the initial velocity, that is initial momentum. Final momentum mv minus initial momentum mu, rate means divided by t. That is F proportional to. So m is common, m into v minus u by t. F proportional to m into v minus u by t. What is v minus u by t? That is called acceleration. Acceleration we discussed in the previous class. A equal to v minus u by t. So instead of v minus u by t, we can write a. So F proportional to m, or F equal to a constant into m. F equal to a constant into m. Okay. If k equal to 1, F equal to m. If k equal to 1, F equal to m. This is the equation to measure the force. So we know first law explains the definition of the force, but here second law explains the equation of the force. What is the equation of the force? F equal to ma. What is F? Force. M mass. A is the acceleration of the object. Okay. So what is the second law of motion? Second law of motion states that rate of change of momentum is directly proportional to the applied external force. Rate of change in momentum is directly proportional to the applied force. Okay, what is change in momentum? Final momentum minus initial momentum. What is rate of change in momentum? Change in momentum divided by time. That is called rate of change in momentum. So we can write second law of motion is F proportional to P2 minus P1 by T. What is P2? mv. What is P1? mu divided by T. M is common. So m into v minus u by T. What is v minus u by T? That is acceleration. So F proportional to m into a. So F equal to a constant k into m. Here the value of k is 1. So we can write F equal to m. This is the equation to find force. Okay. Using these equations, we have to discuss or we have to solve many problems in this chapter. Next, we have to explain the unit of the force. So we know what is the unit of the force. Unit of force is Newton. Newton explained the Newton's laws. Three laws are explained by Sir Isaac Newton. So the unit of force is Newton. Okay. So we know F equal to ma. F equal to ma. Okay. If m equal to 1 kg and a equal to 1 meter per second square, then F equal to 1 kg into 1 meter per second square equal to kg meter per second square is the unit of force, or it is called Newton. Or it is called Newton. This is the unit of force. What is the unit of force? Unit of force is Newton or kilogram meter per second square. Okay, this is the unit of force. Okay, this force is explained by Sir Isaac Newton. Hence, the unit of force is Newton. Then we know there are many applications to the second law of motions. There are many applications. In our daily life, there are many applications for second law of motion. For example, at the time of catching a cricket ball, we move our hands backwards. Why? At the time of catching a cricket ball, we move our hands along with the ball backwards. Why? For reducing the pain. That is the application of the Newton's second law. First application is at the time of catching a cricket ball, we move our hands backwards. Okay. When we move our hands backwards, what happens? Time of stopping increases, or stopping time increases. When stopping time increases, force decreases. We know F proportional to m into v minus u by t. This is the Newton's second law of motion. Rate of change of momentum is directly proportional to the applied external force. So at the time of catching, we gradually move our hands backwards. That time, time increases. When we move our hands backwards, stopping time increases. When time increases, force decreases. Here, force and time is inversely proportional. In this Newton's second law, force and time are inversely proportional. What is the meaning of inversely proportional? Inversely proportional means time decreases, force increases. Time increases, force decreases. At the time of catching a cricket ball, we move our hands backwards. That time increases. When time increases, force decreases. When force decreases, pain or impact or momentum decreases. Okay, this is the application of the second law of motion. Okay, next there are many other applications. Next application is at the time of high jump or at the time of long jump. We jump to a heap of sand, or we jump to a cushion bed. Why? At the time of high jump or long jump, we jump to a heap of sand. Why? To reduce the pain. Okay, that time our legs moves downwards and stops gradually. So stopping time increases. When stopping time increases, force decreases. So the pain also decreases. No pain. These are the there are many other applications. So these are the applications of second law of motion. These are the applications of second law of motions. So today we discussed some points. First point is momentum. What is momentum? What is momentum? Momentum is equal to the product of force and velocity. P equal to mv. What is the unit of momentum? Kilogram meter per second square. Okay, momentum. Initial momentum, mu, final momentum, mv. Then we discussed the second law of motion. What is second law of motion? Rate of change of momentum is directly proportional to the applied external force. F proportional to P2 minus P1 by T. Deriving these equations, we get F equal to m. Then we discussed the unit of force is Newton. Okay, then we discussed some applications of the Newton's second law of motions. Okay, so today we can conclude our class. Okay, thank you.